Welcome to our new video. Today's question is find the nth root of m. You are given two numbers n and m. The task is to find nth root of m. If the root is not integer, then return -1. Suppose input is n equals to 3, m equals to 8. Output is 2. Why? Because cube root of 8 is 2. Now, what is the cube root of 9? It is 2.08 something. You can check on Google. Yeah. So what is because it is not an integer, we will return -1 because here it is saying root is not integer, return -1. What could be the brute force approach? Let's try the knife solution first. Suppose n is 10, we have to find 10th root of what? 10th root of, suppose, or let's say not 10th root, actually it would be much higher. Suppose this is the question. 4th root of 69. We know its answer is -1. Answer is -1. But how to reach that answer? Let's go. Suppose initially answer is -1. Let's make start a for loop from I equals to 1 to I equals to m. Why m? Suppose m is 1. If m is 1, so we have to take this case also. That's why. Now check if suppose power of I comma n. That means we are checking I raised to the power n. I raised to the power n, which is, suppose, for example, if I is 2, 2 raised to the power 4 is 16. We are checking this. Equal m. What is our m? We have answer. This is equal, return. Just return answer I, because it is the ith root. It is the nth root only. If this is not there, we can just break. Actually, we cannot just break. Suppose it is greater than m, actually. Else if it is greater than yeah, if it is less than, then we check ahead. Else if it is greater than, if of I comma n is greater than m, we will just break. Okay, just break and return answer. This is big of m solution. Why? Because for loop is of m times. And what power function takes? Power function internally do binary exponentiation, and it takes log n base 2. Suppose this is another function, we will make a 100 function for this. What can we make? What can be our 100 function? Because suppose n is 10, m is suppose 16. Do we require to, and we will make a power function. Our power function will pass three things: 16, 10, and I is changing from 1 to 16. Suppose I is 2. Let's suppose I is 2. Now how do you calculate the power? You will just do I is equal to you will actually initialize answer to I. Suppose you initialize answer to I. Let's suppose a value to I, and you will make a for loop from int j equals to suppose 1 to n times. You will calculate the power. How? Value equals to value into value equals to value into value. You just have to calculate the power. Suppose if in the middle you are calculating 2 to the power 2 into 2 into 2 into 2 into 2. Here the value of 2 is 16. So you should break. You should not check for these many times. Suppose m is not this. Yeah. So 2 to the power 16. You do not need to calculate 2 to the power 10. You can break at 2 to the power 4 only. If value is greater than, this value is greater than equal to, actually greater than, you can say greater than m. You can just break. You can just break. Greater than, you can just break. So this is the function you can write instead of that. It will take big of n, worst case, for example 1 into 1 into 1 into 1. It will go to 10 times only, so big of n. The time quantities now become m into n, which is bad. So we have to move on to binary search solution. What is the binary search solution? Suppose n is 4, m is 69. What is the binary search solution? We'll make a low pointer, a high pointer, 1, 69. What is the mid? Mid is 35. Now check if 35 to the power 4, 35 to the power 4 is equals to mid m. No. If it is less than m, suppose it is greater than m. What if it is greater than m? So that means everything to the right is also greater than m. So we'll eliminate this part and move to our high to here, 34. Now check mid is, I think 35 by 2 is 17, I think 17. Mid is 17. Now check 17 raised to the power, I don't think it is equal to m. So that's why we'll again eliminate the right part. Everything will be greater than this. I 16, and it is mid is 8. 8 raised to the power 4 is also greater than. We'll eliminate this. Now our low is 1, high is 7, mid is 4. Now check 4 raised to the power 4, which is, I think, greater than m. Yeah, it is also not equal to m. Again we will eliminate. We will move high here. Mid is 2. Now we'll check 2 raised to the power, which is equal to mid. We can return this answer. If suppose we do not get this as it is actually 16. It is actually 16. So this is not an answer. So it is less than. So we'll eliminate the left part. Move to right. What is it right? Move low to mid plus 1. So now low is 3, high is 3, and mid is also 3. Now check 3 raised to the power 4 is 81, which is again greater than m. Again move the high pointer to low minus 1. When high pointer moves here, while condition breaks, we do not get our answer, so we will return -1 only. Okay. Again you can use a power function, which will be log base 2n, or because it uses binary exponentiation. Or otherwise you can make a function, which I have told earlier also. You can make a built-in function, handmade function, which is taking log n in worst case, but it is doing pruning so that it is preventing overflow also. And why we are checking struct based condition, it is breaking early, which is pruning. L equals to I for j equals to 1 to n. We are multiplying. Okay. We are just multiplying, yeah. If at some point value becomes greater than m, we return something, we return 2. If value becomes equal to m, we can return 1, else we can return it is less than, then we have to move only. Keep moving, keep in the for loop, and else return 0. Let's write the code. Now time complexity of this is either, if using power function, you can say it is because it is binary, it's big of log m into log n, or by writing function you can say it is log m into n. So these are the time complexity. Now let's write the code. And low equals to 0 and high equals to 0 is a 0 can't be an answer, so we can write this safely. High is m and answer is -1 initially, and while low is less than equal to high. Let's write the question. And mid, what is our mid? Mid can be, it is 20 only, so int will work. High equals to, sorry, low plus high minus low by 2. If you take this long, it will be safer because we are multiplying it to the power. N can be 9, so 20 raised to the power 9 is too much, I think. Long would be better. Suppose you are using power function. If power equals to power mid comma n, you will check if equal to mid m, return, you can return, just return p, else if it is greater than, else if p greater than m, then we can do high to mid -1, else we can do low to mid +1. Yeah, we can just return now our answer. Yes, let's compile first. It is showing wrong. Why? 27, 1 minute. Answer, we are not updating the answer. We are returning p, but we have to return mid. Okay. Yeah. Wait a minute. We should start from 0, I think, because m can be 0 also. Yeah. Now let's change this power function to our normal for loop, and let's say j equals to 1 to j less than n, j plus plus. Now let's take an answer variable. Let's take long answer. P equals to, initially p is mid, I think. Let's say, then p into p is equal to p into p. If p is greater than m, let's break this loop. Let's check. Actually it is coming wrong. Let me see what's the problem. I think p into p for loop. I think it should be less than equal to. Wait a minute. There is one bug, and we are multiplying by p. We have to multiply it by mid, because we need, suppose n is 4, so we need mid raised to the power 4. So initially we have mid, now it is mid into mid, and when j equals to 2, then mid into mid into mid, j equals to 3, then mid into mid into mid into mid. It is 4 times already. We can remove this and we can write this. See, yeah, and we have submitted. So I hope you enjoyed the video. Hit the like button and we will meet in the next video. Till then, goodbye.